This video continue from the previous video about calculating the live load. Now in the first video about these examples, we calculate the dead load coming on to these steel beams. Now we are like to see the live load coming onto these steel beams. So for that case, we can follow these procedures. Like we need to calculate a live load on both sides of the slab loaded. So for example, one side of the slab is used for office purpose, another side of the slab used for the bedroom purpose. So we need to calculate the live load on the when the both slabs are loaded at the same time. Now first of all, we can start from here. How much live load coming from this 2-point load onto this steel beam. So now before we have taken the UDL load is equal to 2 times P. So I can write it down this one here. We can have a 2 times P on 10, and this P is coming from this P, and there are two. Number 2 is coming because there are 2, and 10 meters coming from these 10 meters because 5 meters here, 5 meters here, so total 10 meters coming from here. So that's the UDL load, and this equal to 2 times 20, and now this 20 is coming from here. Live load of 20 kilonewton, that is given in the question. So that 20 is substituting here. 2 times 20, 40 over 10 is give you 4 kilonewton per meter. So this is the UDL load on these steel beams due to this one. So if you imagine this UDL load going to apply in these fashions, like this due to this loading. Now we are interested in point load because this will create the point load onto this. When you are looking for from this side, it will create the point load on this one. So the equation for calculating the point load to the UDL load is equal to parallel length. So 4 kilonewtons times 5 meters. So if I am talking about, let's say in the previous mechanics of solid, we done many of these example where we have 4 kilonewton per meters, and if it is 5 meters, now we can say that this one would be 4 times 5, which is 20 kilonewtons as a concentric load. So that was 20 kilonewtons. Now that is the point load. Now we need to because in the question it says that one side of the slab is used for office purpose and another side of the slab is used for bedroom. So in that case we can find the live load for office. So how much, for example, one side of the slab used for office, for example this side is used for office, so how much live load is carried on the slab due to the office activity. So in that case we need to go to Australian standards. I can open the Australian standard here in AS and NZS 1170.1 in the page number 9 at table 3.1. somewhere here in the section B we have office, and we are going to use office for general purpose. So it has a live load given 3 kilopascal. So that's what I am going to use. That is 3 kilopascals taken from table 3.1 page 1 of AS and NZS 1170.1. So that is the live load applying on this one like a pressure onto office. Now other section of the slab is used for bedroom. So for example here bedroom, so how much pressures are applied due to the live load activity of bedroom. So we have bedrooms equal to, now the bedroom has given here in the section A2, same Australian AS NZS 1170.1 2002 on page number 9 on table 3.1. in section A2 we have a general area and bedrooms. In that case we have 2 kilopascals. So that is 2 kilopascals taken from this table 3.1. Now for UDL, for the office purpose, we know the pressure of the office the live load coming from office. So we like to convert into UDL. So pressure times the perpendicular length give you the UDL. So 3 kilonewtons times the, so for example this for this on these steel beams, this will create the UDL load in this direction. So if you are looking from this side, so this will create the UDL load in this fashion. So this UDL times the perpendicular lengths will give you these pressures times the perpendicular lengths give you the UDL load. So we like to multiply this perpendicular length, which is 5 meters. So this 3 kilonewton meters, so that is coming from here, and times perpendicular length is the perpendicular length is this one, because the UDL load going to applied along the length of the beam. So that is 15 kilonewton per meters. That is UDL load for office purpose. And UDL for bedrooms, and we have same pressure times length. Now for bedrooms, which is here, so in that case bedroom will have a 2 kilonewton per meter cube, that we 2 kilonewton per meter square, sorry. So that is taken from table 3.1 times the perpendicular length. Again, this perpendicular length is this 5 meters, so that give you 10 kilonewton per meters. Now we can draw the line diagram that is given in the, that is asking in the questions. These steel beams, so I draw these steel beams 8 meters, so I draw these steel beams like this. I draw it here 8 meters, which is 8 meters. This concentric load that is coming from here in the middle at 4 meters, so I can put it here 4 meters, and that 4 meters coming from that we calculated here 20 kilonewtons at the first due to 2 concentric loads, so that is 20 kilonewtons. And then we have one side of the slab 4 meters, which is office, so we have office, and it has a UDL load of 15 kilonewton per meters, which we calculated here 15 kilonewton per meters, which is for office, so we put 15 kilonewtons. And other side of the slab used for bedroom, so in that case we have this UDL load for bedroom, and that is 10 kilonewton per meters. So that is the UDL load line diagram. Thank you very much.